Hello, everybody. This is Miss Martinez. Today we are going to learn about how to create a quadratic equation from a graph. We talked about this a little bit last Friday if you were here in the Jumpstart. But basically we're going the opposite way of taking the equation and then graphing it. Now we have been given an equation and we need to write our equation in vertex form, which we know is y equals a times x minus h squared plus k. So our graph here that we have is of a projected object. Remember, we talked about projectile motion with the winter snow activities a couple weeks ago. So this is just saying that from the ground level, an object is projected upward. So from the ground here, we're going upward. The graph represents the height in feet of the object at time t in seconds. So then that object will come back down and land again, creating the shape of our parabola that we know for quadratic functions. Okay, and this one's opening down. So that just gives us a little bit of context with what we're working with. And so we're going to write an equation for this graph. So we can just label that height is h. That's our y-axis here. And then time is t, which is our x-axis here. Okay, so first thing to do in order to write in vertex form is to identify your vertex. So remember that our vertex is HK. When we're talking about our vertex form equation. Okay, so the vertex is the very, very high point where the object reaches its maximum height up here. And so what is the vertex? Okay, good. Our vertex is 416. So 4 would be h, and 16 would be k. Okay, next it says to determine the width. So there's 3 different types of widths that we could have. And see, our width is basically helping us identify our rate. Right, we've talked about if it has a normal width, then A is 1, our rate is 1. So let's kind of make a chart here to help us. So if A is equal to 1, then we have what we call normal width. If A is greater than 1, well, and I guess we should say it's the absolute value of A. Okay, things like 2 and 3, but also -2 and -3. This is going to make our graph get skinnier. It stretches it. So we have a skinny width. If the absolute value of A is less than 1, so where we have our fractions or our decimals, like 1/2 or -1/2, then this is going to give us a wide width. Okay, so what we're going to do is, in order to determine this, you're going to look between the first 2 points that you can find on either side of the vertex. So if I go up to my vertex and I go over 1 on each side, I've got a point here and then here. So I need to determine the rate that's happening between the vertex and that next point. So I go down 1, and then I could go right or left 1 to get to that next point here. So the rate that's happening between those first 2 points is -1/1. So that means my A, that simplifies to -1, so A is -1. So does this mean that I have a normal, skinny, or wide width? Okay, good. This means I actually have a normal width. But because it's negative, it's opening down. It's been reflected. Okay, so this will be super helpful in us writing our equation of this quadratic. We know our vertex, and we know that A is -1. So now we can plug these into vertex form, which we know is y equals A times x minus h squared plus k. So we're going to replace the a, h, and k. So instead of a, we know a is -1. Okay, and then we're going to multiply that by x minus h, which is 4. Squared, and then plus k, which is 16. And so then I have my equation of my first quadratic function here. Oops. Let's make that a little thicker. Okay, we've got 2 more examples. Now these ones, you might notice right off the bat, one of them looks skinnier than normal, and the other one should be a little bit wider. So these are going to be 2 examples where A is not 1 or -1. So we'll see how to do that. Okay, starting with this one on the top right. We're going to determine our vertex first. So what is the vertex of this graph? It's right down here. Okay, good. It should be at the origin 0, 0. Okay, now we need to determine the width. So we're going to find the first 2 points on either side of the vertex that are over only one box, right? So see, only over one box. The points that give me that are the 2 black dots up there. So I'm going to find my rise over run to get to those 2 points because that'll give me my rate. So I need to rise 1, 2, 3, 4 boxes. And then, of course, run 1, because that's what we were looking for. How much do we rise when we run 1? Okay. So the rate is 4 over 1, which simplifies to 4. So A is 4. Now, does this make our graph have normal, skinny, or wide width? Good, it is skinny. Okay, so now we can plug these into our vertex form equation. So we will have y equals, instead of A, we'll replace this with 4. Multiply by x minus h, which is 0, squared, and then plus k, which is also 0. So look what I've just done here. Both h and k are 0. Remember that when you add 0 to anything, it doesn't change itself. So this is a valid way to write the equation, but most of the time you will see this written even more simplified without the zeros. Okay, you'll see it as y equals 4 times x squared, because if I subtract 0 from x right here, that's just x. The squaring will still happen, so I'm going to keep the x squared. And then if I add 0 on at the end over here, that doesn't change anything either, so I don't have anything to add on at the end. So this is the most simplified vertex form of this graph. And I can tell by looking at that h is 0 and k is 0 because nothing's there. Okay, let's do the last example. So what's the first thing we need to identify here? Yeah, we're going to do our vertex. So that is the high point of this graph here. And this one is also at the origin. So our vertex is 0, 0. Now we need to determine our width. So after the vertex, we're going to run 1. Okay, and find the point on the graph that's over 1. So I'm actually going to add in a couple points here. One right here. You should do this on your paper if you can. Because notice where I'm drawing these points in is over 1 box away from the vertex on either side. I'm going to find how much I rise from that point. Okay, so it looks like I go down about halfway. So I'm going down 1/2, and then I'm going over 1. So for my rate, since I'm going down, that's negative. So that would be negative, we can say 0.5, since that's the same as 1/2, over 1. Well, this is going to simplify to negative 0.5. Anything divided by 1 is just itself. So we could use negative 0.5 or negative 1/2 for this width. And so this will create a wide width. And you can double check that. That is half the size of our normal rate of change pattern. Remember, our normal rate of change pattern is to rise 1, run 1. Well, we only did half of that. So we know that A must be 1/2. And then from the second point to the third point, we go down what it looks like 1.5. So down 1.5, but over 1. So that is half the size of the next pattern that we learned last week. After you rise 1, run 1, then you rise 3, run 1. Well, rising 1.5 is half of 3. So that's how we can double check that our A is correct. Okay, so now we can write our equation. Y equals A is negative 1.5. I'm sorry, negative 1/2. Or negative 0.5. Times X. And then minus 0 for H again. Squared. Plus K, which is also 0 again. And just like we talked about last time, since our vertex is at 0, 0, this is not the most simplified that we could write this equation. And you typically won't see it written this way. So we're going to write it fully simplified as Y equals negative 1/2 times X squared. Okay, because remember, X minus 0 is just X. And then anything plus 0 is just itself. So it doesn't change anything at the end there. So this is our final answer. Okay. Hopefully this helped. I know we don't have this printout, but in the agenda, I put it in there. So if you have a printer, you are able to print it. If you don't, or you did not, then you can just copy this down in your notebook and use the PDF to reference to. And I will be posting the full key for this as well. And this should help you on your matching activity that is due tomorrow. Okay, thank you so much. Let us know if you have questions.